Every American experimental aircraft ever built, from Wright Brothers to hypersonic dreams. Subscribe for more videos. Let's begin. Early aviation. The pioneers push boundaries. Wright Flyer variations. Learning to fly better. After the brothers proved powered flight worked on the sand dunes of Kitty Hawk in 1903, they spent years experimenting with different wing configurations, control surfaces, and engine placements. Each variation taught them something new about how air moves over wings and how to control machines in three-dimensional space. The Wright brothers understood that the first flight was just the beginning. True mastery required endless experimentation, endless failure, endless learning. They built versions that flew in circles, versions that could carry cargo, versions that proved controlled flight was possible at all. Curtiss Pusher, the propeller innovation. Glenn Curtiss designed aircraft with propellers mounted in front, pushing rather than pulling. This simple change in configuration opened entirely new possibilities for aircraft design. The pusher configuration allowed different fuselage layouts and exposed the pilot more to the elements. Curtiss experimented relentlessly with pusher designs, eventually switching to tractor configurations when aerodynamics proved them superior. His willingness to question the Wright brothers' tractor design showed that American innovation thrived on competition and alternative thinking. Martin T-Tractor, the early bomber concept. In 1913, Glenn Martin built the T-Tractor, an aircraft designed to carry bombs and reconnaissance cameras. It represented some of the earliest thinking about aircraft as military weapons rather than sporting novelties. The T-Tractor featured a powerful engine, reinforced airframe, and bomb racks underneath the fuselage. It never saw combat, but it established the fundamental concept of military aviation that would dominate the 20th century. The rocket age, strapping engines to airframes. Bell X-1, breaking the sound barrier. In 1947, test pilot Chuck Yeager climbed into the Bell X-1, a missile-shaped aircraft designed solely to reach supersonic speed. Launched from a B-29 mothership at altitude, the X-1 used a rocket engine to accelerate beyond Mach 1. At 45,000 feet, Yeager pushed the stick forward and felt the aircraft shake as it passed the sound barrier. For an instant, everyone thought the plane would tear itself apart. Instead, it smoothed out. Yeager had become the first human to break the sound barrier. The X-1 proved that supersonic flight was not just possible, it was survivable. Bell X-2, pushing hypersonic speeds. Building on X-1 success, the Bell X-2 was designed to reach Mach 3 in altitudes exceeding 100,000 feet. This tiny aircraft pushed the edge of human capability and aircraft structural limits. Test pilot Mel Zabel flew it to Mach 3.2 before a structural failure forced him to eject. The X-2 proved that hypersonic flight was possible, but demanded solutions to heat, materials science, and control that did not yet exist. Every flight generated data that informed the next generation of experimental aircraft. Douglas X-3 Stiletto, the needle-nose speed machine. This aircraft looked like a flying knife, with an impossibly slender fuselage and short wings. Designed for Mach 2 speeds, the X-3 featured unusual design choices that seemed to defy aerodynamic logic. Yet it flew beautifully and proved that unconventional layouts could achieve exceptional performance. The X-3 taught engineers that assumptions about what worked could be wrong. It generated thousands of hours of flight data that challenged and refined aerodynamic theory. North American X-15, the spaceplane. The X-15 was less an airplane and more a rocket with wings. Dropped from a B-52 at altitude, it used an XLR-99 rocket engine producing 57,000 pounds of thrust to accelerate to hypersonic speeds. Test pilots flew it to Mach 6.7 in altitudes exceeding 354,000 feet, high enough to see Earth's curve and qualify as spaceflight. The X-15 proved that hypersonic flight and near-space operations were survivable. Every mission gathered data that informed spacecraft design. The X-15 became the bridge between aircraft and spacecraft. Alternative designs, lifting bodies and flying wings. Northrop XB-35 flying wing, the radical bomber. In the 1940s, Northrop designed a bomber that was nothing but wing. No fuselage, no tail, just a massive wing shape that generated lift across its entire surface. The XB-35 featured two piston engines and internal bomb bays. It flew well, but suffered from control difficulties and manufacturing complexity. The concept was revolutionary. The execution was ahead of its time. Northrop would return to flying wing obsession in the 1980s with the B-2 Spirit, proving that good ideas sometimes just need 40 years and better materials. Northrop YB-49 Jet Flying Wing, the jet-powered dream. Taking the flying wing concept and adding jet engines, the YB-49 represented Northrop's attempt to create a jet strategic bomber without conventional fuselage or tail. 8 Allison jet engines powered this flying wing design. It flew magnificently and proved jet flying wings were feasible. But stability problems and a catastrophic crash killed the program. Northrop's obsession with flying wings would be vindicated decades later when composite materials and computer control made the concept practical. Martin Marietta X-24 Lifting Body, the spacecraft alternative. Lifting bodies were aircraft that generated lift from fuselage shape rather than wings. The Martin X-24 looked more like a brick with a window than an airplane. It was designed to explore how unconventional shapes could generate lift and be controlled through thin air at hypersonic speeds. Test pilots flew it as a glider dropped from B-52s and later with small rocket engines. The X-24 proved that lifting bodies could work, generating data that influenced space shuttle design. HL-10 Lifting Body, the Flying Potato. NASA's HL-10 lifting body resembled a potato with a tail. Despite its ungainly appearance, it generated tremendous lift and proved remarkably controllable. Test pilots flew it hundreds of times, pushing it to higher speeds and altitudes with each mission. The HL-10 proved that aerodynamic shapes could be optimized entirely around lift generation at hypersonic speeds. Every flight taught engineers something new about how thin air flight behaved. Vertical takeoff, defying gravity without runways. Bell 15-15 Tiltrotor, the hybrid dream. Imagine a helicopter's rotors on airplane wings that could tilt from vertical to horizontal. The 15-15 proved this concept could work. Twin propellers mounted on wing pods could rotate from pointing straight up for vertical takeoff to pointing forward for supersonic cruise. The 15-15 flew like magic, straight up like a helicopter, then the rotors tilted and it flew like an airplane. It was the future of vertical takeoff, but the future took longer than anyone expected. Convair XFY-1 Pogo, the tail sitter. Some experiments seemed brilliant until you tried them. The XFY-1 was a fighter that took off and landed vertically on its tail, like a rocket. The concept was clever, vertical takeoff from tiny spaces without runways. But flying tail-sitter aircraft proved disorienting for pilots who had to look up or down the entire fuselage just to see ahead. The XFY-1 flew successfully but was too strange, too uncomfortable, too alien for pilots trained in conventional aircraft. Sometimes weird ideas are just too weird. Hiller X-18, the tilt wing experiment. Rather than tilting rotors, what if you tilted the entire wing? The Hiller X-18 featured a wing that could tilt from vertical for takeoff to horizontal for forward flight. It proved the concept could work mechanically and aerodynamically. Test flights showed that tilt wing designs could transition between vertical and horizontal flight. But complexity, weight, and fuel consumption made the concept impractical. Vertical takeoff remained a dream pursued but rarely achieved. Supersonic exploration, pushing Mach numbers. Republic XF-103, the Hypersonic Interceptor. This interceptor was designed to climb to extreme altitudes and penetrate high-speed bomber formations using ramjet propulsion. It featured a needle-like fuselage and delta wings optimized for supersonic flight. The XF-103 represented American thinking about how to intercept Soviet bombers flying at Mach 3. Only prototypes were built. The concept proved feasible but obsolete. Missiles would eventually make manned interceptors unnecessary. Convair XF-92, the first delta-wing jet. This tiny experimental fighter featured the first operational delta-wing design. Built to test delta-wing aerodynamics at transonic and supersonic speeds, the XF-92 had no horizontal tail surfaces. All control came from elevons on the delta wings. It proved delta wing designs could work at supersonic speeds, influencing designs like the F-102 and F-106 that followed. Sometimes, small experimental aircraft shaped the future of aviation. North American X-10, the Mach 2 testbed. This sleek aircraft was designed to investigate flight characteristics at Mach 2 and extreme altitudes. Powered by a single General Electric J79 turbojet, it looked like a scale model of what a Mach 2 fighter might be. The X-10 flew hundreds of test missions, gathering data about supersonic aerodynamics, control characteristics, and structural stresses. Every flight refined understanding of how aircraft behaved at twice the speed of sound. Stealth technology, invisible innovation. Lockheed have Blue, the first stealth fighter. This small aircraft looked nothing like a fighter. Faceted surfaces covered the fuselage at unusual angles. Rounded surfaces were replaced with flat panels. Straight edges eliminated curves. The entire aircraft was designed to minimize radar reflection. Have Blue flew in secret from Area 51, proving that stealth technology could work. Every flight brought new understanding of how to hide aircraft from radar. Have Blue's success led directly to the F-117 Nighthawk, the first operational stealth fighter. Northrop Tacit Blue, the stealth technology demonstrator. While Lockheed worked on stealth fighters, Northrop pursued a different approach. Tacit Blue was a larger, more sophisticated stealth demonstrator designed to test advanced sensor systems and stealth technology. It flew for years from secret locations, proving that stealth design principles could scale to larger aircraft. Tacit Blue's success contributed directly to the B-2 Spirit stealth bomber program. RQ-180 reconnaissance drone, the classified stealth. America's next-generation reconnaissance aircraft is so classified that official acknowledgement remains denied. The RQ-180 reportedly combines stealth technology with long-range reconnaissance capability. It allegedly operates over denied territory, gathering intelligence that conventional aircraft cannot reach. Whether it exists or not remains one of aviation's great mysteries. The RQ-180 represents the future of stealthy long-range surveillance. Advanced concepts, pushing into the unknown. Northrop Grumman RQ-180 stealth drone, the ghost in the sky. This aircraft combines stealth technology with persistent surveillance capability. Operating at extreme altitudes and speeds, it gathers intelligence from areas protected by advanced air defenses. Every detail remains classified. Every capability is speculative. The RQ-180 represents where aviation goes when classified budgets exceed public knowledge. It is the future already flying. Scaled composites, SpaceShipOne, the private spaceflight pioneer. Designed by Burt Rutan and launched from a mothership, SpaceShipOne proved that private companies could build spacecraft. It reached suborbital space and returned safely, winning the Ansari X Prize. SpaceShipOne proved that unconventional design and private innovation could achieve what only governments had accomplished. It launched the age of commercial spaceflight. Boeing X-37B orbital test vehicle, the unmanned spaceplane. This unmanned spaceplane launches on top of an Atlas V rocket, operates in orbit, and returns to Earth for landing. What it does in space remains classified. How long it stays aloft remains secret. The X-37B represents the future of military space operations. It is a spacecraft that looks like an airplane, launched like a rocket, and operates like a satellite. It proves that space warfare is already here. DARPA HDV-2 Falcon Hypersonic Glider, the Mach 20 weapon. This unmanned hypersonic glider was designed to be launched from a rocket and glide to Earth at Mach 20 speeds. It would reach targets on opposite sides of the planet in under an hour. The HDV-2 proved that hypersonic flight was achievable, but that control and guidance at those speeds remained extraordinarily difficult. Several test flights ended in loss of vehicle, but each mission brought understanding of hypersonic flight physics. Aurora Project, the classified hypersonic reconnaissance. Rumors of a hypersonic reconnaissance aircraft called Aurora have circulated since the 1980s. Allegedly faster than Mach 5, supposedly launched from B-52s, the Aurora remains unconfirmed. Whether it exists or not, It represents the limit of what classified aviation budgets might produce. The Aurora is either the most advanced aircraft ever built or the most elaborate aviation myth ever created. Modern experimental, the current frontier. Sikorsky S-97 Raider demonstrator, the high-speed helicopter. This experimental helicopter combined helicopter vertical takeoff with airplane forward speed. Short, stiff, pusher propellers and pusher rotors allowed speeds approaching 250 miles per hour while maintaining vertical takeoff capability. The S-97 proved that high-speed helicopters were mechanically feasible, but that pilots found them disorienting and that operational advantages were limited. Bell V-22 Osprey tiltrotor, the marine solution. Originally designed in the 1980s but not operational until the 2000s, the V-22 Osprey proved that tiltrotor aircraft could work in military service. Twin engines on rotors that tilt from vertical to horizontal provide both helicopter vertical takeoff and airplane forward speed. The Osprey's success vindicated decades of tiltrotor research and experimentation. Lockheed Martin F-35 Lightning II variants, the shapeshifter. The F-35 exists in 3 variants: conventional takeoff, carrier-based, and short takeoff vertical landing. Each variant represents different experimental approaches to single-engine stealth fighter design. The development process involved thousands of test flights and experimental configurations. The F-35 proved that advanced stealth fighters could be adapted to radically different operational requirements. Boeing Phantom Ray, the stealthy demonstrator. This unmanned stealthy aircraft demonstrated that autonomous flight and stealth could combine for persistent reconnaissance. Powered by a single turbofan, the Phantom Ray featured faceted stealth surfaces and autonomous flight control. It proved concepts for future unmanned combat systems. XQ-58 Valkyrie, the autonomous wingman. This unmanned stealthy aircraft was designed to work alongside manned fighters as an autonomous wingman. Operating on internal fuel and carrying weapons internally, the Valkyrie proved that unmanned stealth aircraft could perform complex missions. It represents the future where pilots command unmanned aircraft as teammates rather than tools. Subscribe for more videos.